Hello all and welcome back. So in this video, let us now move forward with our discussion on hash maps. And now let's try to implement our own hash map using chaining. So in the last video, we were able to implement our hash map using the open addressing technique. Now we did linear probing, but I'm pretty sure that you can do the quadratic probing as well as just implementing another hash function, right? So different methods of probing you could easily do. Now coming to implementation using chaining, okay? Many people find the code a lot difficult for this, but honestly, I like the code very much. The reason is that it actually tests you on lots of skills. So each and everything will be a linked list. So it tests on your understanding of linked list. Along with that, exactly how things are happening. If you're able to just focus on a single operation and code it out, that enhances your coding skills a lot. Okay. So our approach here will be that one by one, we will try to understand each and every operation and then try to write the method for it. Okay, great. So let us begin, everyone. Now, before we go to code, let me just first explain you the approach again, right? Because if that will be clear, then it will be a lot easier for us to code. So in chaining, we will be taking one array or a list, right? So let's say this is one list. Now this list, and let me make it a little smaller. So let's say this is the list. This list is known as buckets. This time we will not be taking two lists, one with keys or values. Rather, we will be taking a single list and each and every element of this list will be a linked list head. Okay. So understanding of linked list is very important if we want to implement the chaining, right? Because each and everything is a linked list here. So effectively, each and everything here is a head of my linked list, right? So something like this is actually happening, right? Initially there will be none, but yes, as we move forward, so initially there will be none, and as we move forward, we will be adding elements just like we add in a chain. Okay, great. So this is known as buckets. Anytime you give me a key, you will also be giving me the value, right? So when we learned about our linked list node, we saw that how it can have a data and a next. Now this basic node, linked list node, will change into something like this. So pay attention, everyone. It's going to change into something like we will be saving. So we will be saving key, value, and the address of next. Okay, so this is how our overall node of a linked list will change. So we will also have a key and a value. So instead of data, okay, we will be storing key and value. The approach is going to be the same. I'm going to find out that which bucket index, where exactly my this element, this entry wants to go. I will go there. I will check if that is none. If it is, I'm going to enter it. If not, I'm going to start my linked list. Next time, if the element want to go to the same location, then instead of doing or finding another place, I will be making sure that I add to it only. Okay, everyone. So let us see this in action as well, because I want that here each and everything should be clear. If we take a minute extra to implement, that is fine. But you should have everything visualized properly so that you can explain tomorrow someone as well. So pay attention, everyone. This is again a very good visualization which I found. I will be sharing the link of this as well. So pay attention. See, this is one bucket array. Each and everything is none as of now, right? Let's say it is having the size of 13. Let's say I want to add 10. So element 10 will get added here. See, it started a linked list. This is none and a linked list is started. Now say I want to add 23. This time also 23 wants to go to 10. So instead of doing linear probing, we add it to our head, right? This particular visualization approach is not making any key or value distinction, but we want to make sure that we are able to store key and value both. Okay, great. So let us start and do it step by step. The very first thing which we will be working on is, because the basic idea is the linked list, right? So we will be writing the linked list operations first. Okay, so will be very straightforward. Few of the operation we have to write just. So let us start with them, everyone. Okay, great. So let us actually create a file, new file. So it is, let's say, link list for chaining. Just to keep the code clean, the very first thing, okay, is the node of this linked list. Class node. Let me write ll node. This time it is not having the data and the next. It is having different things. So self init key value. Okay, great. First thing, self dot key. This is going to be key. Self dot value, going to be value. Self dot next, going to be none. Okay, we have to take init here. Okay, so I messed it up. My bad. Init, and this is self. Okay, great. So this is the node. What effectively this has done, everyone? It has created a node in the memory wherein we are having two things here. So this is having the key, it is having the value, and the next, which is none initially, right? So this is how our node will be. As we talked about, we can have anything which we want to store in our linked list, right? We were earlier just saving the data, but doesn't matter. We can say multiple things as well. Great. So this is done. Now let us try to create a linked list class. Okay, a linked list class. So this will be a little different because now I will be working on keys and value, right? So few changes will be there, but I'm pretty sure that if you have written the code in the linked list module, you will face no problem whatsoever in this particular understanding. And the reason I'm not copy pasting it is that I want you to understand that what exactly are the minor changes which happens in different implementations. Okay, because the real approach is just to implement, right? We can anyway use the dictionary which is inbuilt in my Python, but to implement, to understand and to explain, we should be having a proper idea. Great. So very first thing is going to be just the constructor, and I think I just need my head. Okay, so initially as we take, a linked list is going to be none. Great. Now let us see what are the different operations which we have to perform. If I add 36 here, it means, and just focus on this particular node, okay, forget all the other nodes as of now. I think that I am able to add to this particular linked list, right? So there should be a function, and let us make it add only. If you provide me with a self will of course be there. If you provide me with a key and a value, okay, then in this linked list, I should be able to add that. So key value, then new node dot next equals self dot head, and self dot head equals new node. This is the exact code which we write for adding to a head, right? So if we will see here, so 36 plus 13, around 49, if we add, it is getting added to the head. O1 complexity, we have to do nothing, right? Great. We will come to our hash map, no problem. But first we need to make sure that how or what are the changes which this key or value is going to do. Great. So this is the add function. Now let's talk about the next function, which is going to be search, I believe. Okay, so let's say if I want to search, let's say I want to search for 10. What will happen? Key will be passed, and then I have to search for 10 in this particular linked list. And I will be able to do that. Once I'm able to check or find my key, I will say that, hey, I have found the same. So each and every of my node will also have a search functionality where you will just give me the key. Okay, great. So add is done. Now we are just doing the search functionality. Current self.head. So I will be starting from self.head just like it happened here. Again, let us see that 10. Fine. See, I went here, then 1, 2, 3, 4. Unless it becomes null, right? If I, let's say, want to find for 49 plus 13 is 62. So it will go here, not found, not found, not found, not found, and it has become none. So now we can say that it is not found, right? Again, something which we have done. While current is not none, we will keep on increasing this current. So current equals current dot next, right? This is what we will do, everyone. But if I'm able to find the key, if current dot key is equals to key, then we should just return the node. Okay, so pretty sure that this is a lot clear, everyone. And if you are not able to find anything, then we should return none, or we can return not found. Like none is as good to handle it as we want. Great. So this is just one more operation, everyone, and we want to make sure that we are able to do these operations in my linked list only, so that the code for my hash map becomes a lot clean. And I think this is a very great strategy as well. The reason for that is, if we have these things separate, then I know here I just have to think for the linked list. When I will write my hash map code, I just have to think for my hash map. Great. So now let us write the next overall code, everyone. So let's say I want to now delete 10. The understanding again is very easy. You just have to search for 10 in a way. Okay. And we have to delete it. Okay. So see, it will going to search for this and it will delete it. See, simple work, right? If I say delete 11, then it's a problem. The reason, it will go here. It is none. So it will not do anything. Element is not in the table. Great. So let us now see how delete will happen, everyone. Delete. Okay. So self, and you will give me the key. So each and everything is happening with respect to key. Just that value is something which I'm storing along with my key. In the visualization which we saw, again, we are just dealing with key. It doesn't care with the value as well, right? Great. So now let us write the code for this. What exactly do we need to do? Let us understand that first. Okay. Great. So there can be multiple cases, right? Let us see that. I think insert and search is pretty clear. Let us see for delete. Okay. Delete, we have multiple cases which we have handled in our linked list as well. First, if node is head, that is pretty easy. If the node found is head, then we can easily say that, hey, just delete, right? Not a problem. We will just directly say that, hey, head, please focus on the next one where you are focusing. Great. Second, when let's say we have a structure, something like this. So let me draw this linked list. Great. So let's say I want to delete this node. What I effectively do, okay, are two things. Either I should be on this node and say that, hey, I have found the node. I am focusing on now this node. Or what we can do, we can take a previous and a current as well. So we can have this kind of a two-pointer approach as well, where once I get that, hey, my current is this particular thing, then I can just ask my previous to focus on this instead, right? Something again which we have seen already, everyone. These are the two approaches. Now, if you remember, in questions also, you must have used this approach. So we can write on any approach. I am going to use the previous and current one so that you are also aware of this particular approach as well. Okay. We will keep on going until we reach none. Because once we have reached none, then I can comfortably say that that particular node is not present. Okay, great. So let us see that, everyone. What I have to do, first current will be equal to self dot head, and I'm taking previous as well. Previous. Okay, it's none. Why am I doing it this way? Pay attention. Let's say I want to delete 36. Okay, see how it will delete it. It will go here, then next, and now it will delete it. Okay, so we are following the same approach what we see. That's the major reason. We are not deleting it when we are on the previous overall node. So while my current is not none, while I'm saying the current is not none, now if current dot key, okay, if the key is equals to key which I'm looking for. So I have given you a key here as well, right, everyone? If you find the key, then we can delete. But there are two cases. First one, if previous is none. What does that mean? If previous is none, that means that the current is head only. So that means that we are removing the head. Okay. What does that effectively transforms to? Self dot head. Hey, head, can you please focus on the next one? Now it can be none. I don't care. It can be none as well. Okay. Let us see that also 49. 49. Go here and delete it. So head, please focus on the next one. That is what it has done, right? Great. So this is the one case. Next case is when previous is not none. If that is the case, I just have to ask my previous dot next to focus on current dot next, right? So when let's say my current, this is the node which I have to delete. I am on previous. I am just asking, hey previous, please focus on where current is pointing. And this will be out of my linked list. So this is just what I have to do. And if we have deleted it, then we can return true. We are taking a single case only. If this is not the case, then what I have to do? I have to say that, hey, previous, you become current, and current, you become the next one. This is just the approach which we have to follow, everyone. And if we are able to delete, we will return true. Else, we can just return false. Pretty straightforward work. Okay. Pretty sure that if you have understood linked list pretty nicely, we will be able to understand all these codes, right? We'll suggest to see the linked list module again if you have any doubts, but I'm pretty sure that I've explained it again, right? So not copied that so that each and every one of you are comfortable. Great. Let us write one more overall code because we have a good visualization here. The same might not be present in our code. So for that, we need a traverse function as well. Okay. So traverse, I will just be getting the head. Current, I will say is overall self dot head. So my linked list head. Okay. While current is not none. Okay. What I have to do? Print, I can just print the value and the key. So current dot key using the F formatting, everyone. So we can enter it here. Current key, current value. Okay. And we can just join it like this. We have the end like this. Great. So this is what my traverses do, and I should just keep on moving to current dot next. And when this is done, I can just print none in the end so that it is in line with my linked list structure. So once we create, we are going to see how that happens. Great. So now we have worked upon each and every element of my linked list, right, everyone? Now, if all this I have written pretty nicely, which I believe we have, we should be very easily now be able to implement our hash map. Okay. Please make sure that you understand each and every line in this code. This is something which we have already done. If you are able to understand this, then now hash map code will be a lot easy. I have intentionally make sure that I am dividing it in such a way that it is very easy to understand for anyone. Okay. So great, everyone. Now in the next video, we are going to start with our hash map using chaining code. But honestly, I think we are done with 50% of the work, even 70% of the work, because now we just have to use this methods by checking that where my overall, which overall index I have to work on. Okay. So great, everyone. Let's meet in the next video and then just complete our hash map code.